Konganadu College of Engineering and Technology, Department of EEE, Subject Code 24EE302, Electron Devices and Circuits. The faculty name Mr. P. Sridhar, AB bar EEE. So here we are going to study about the Unit 5 Power Amplifiers and Special Devices. Here power amplifier means 4 types of amplifier: Class A amplifier, Class B power amplifier, Class AB power amplifier, Class C amplifier, Class D power amplifier. And then special devices means LED, LCD, Schottky diode, varactor diode, photodiode, and then phototransistor and optocouplers. And these are all the special devices we are going to study in this Unit 5. So now we are going to discuss about the special devices, that is called LED, light emitting diode. So these LED increasing uses of display device in calculator, watches and all forms of instrumentation has contributed to the current extensive interest in structure that will emit light when properly biased. The two types in common use today perform this function are the light emitting diode and the liquid crystal display LCD. The light emitting diode is a diode that will give off visible light when it is energized. In any forward biased PN junction, there is within the structure and primary close to junction a recombination of holes and electrons. The all semiconductor PN junction, some of this energy will be given off as heat and some in the form of photons. The silicon and germanium, the greater percentage is given up in the form of heat and the emitted light is insignificant. In other materials such as gallium arsenide phosphate or gallium phosphate, the number of photons of light energy emitted is sufficient to create a very visible light sources. The process of giving off light by applying an electrical source of energy is called electroluminescence. Next one, the process of electroscience in the LED and its graphic symbol. So here the LED is both side, it will be placed in metal contact for positive terminal and negative terminal. This top of the layer, the arrow mark indicating for emitted visible light, that means the brightness is go through the flow through the outside. It's a symbol. So the positive is indicating for anode and the negative is indicating for cathode. The arrow mark direction indicating for this outside. That means the brightness illuminated to the outside of the surface. The conducting surface of the P materials is much smaller to the emergence of the maximum number of photons of light energy. The recombination of the injected carriers due to the forward bias junction result in emitted light at the site of recombination. There may of course some absorption of the package of photons energy in the structure itself, but a very large percentage are able to live as shown in the figure. Next one, LCD, that means liquid crystal display. So this liquid crystal display has a distance advantage of having the low power requirement than the LED. It is typically in the order of microwatt for the display as compared to the same order of milliwatts for LEDs. It doesn't however require an external or internal light source and is limited to a temperature range of about 0 degree to 60 degree Celsius. The lifetime is an area concern because LEDs can chemically degraded. The types receiving the major interest today are the field effect and dynamic scattering units. A liquid crystal is a material normally organic for LCD that will flow like a liquid but whose molecular structure has some properties normally associated with the solids. So these are all the LCD basic structure. Here this liquid, and then incident light, and then indium oxide. So 0 voltage, that means conductive clearing coating, and then spacer and sealer. So these upper and lower glasses are the outer glasses. So this incident light, that means the LCD liquid crystal display, the crystal emitting through these in the form of output, that is the display devices. The individual molecules have a rod like appearance as shown in this figure. This arrow mark is look like act as a rod or appearance. It will be shown in this outside of this display. The indium oxide conducting surface is transparent, and under the conditions shown in the figure, the incident light will simply pass through and the liquid crystal structure will appear clearly. So this circuit diagram for this spacer and sealer, liquid crystal, glass material, clear region, incident light, and then focused region, indium oxide. So the molecular arrangement is distributed with the result. That region will be established with different indices of refraction. The incident light is therefore reflected in different direction at the interface between region of different indices of refraction, with the result that the scattered light has a frosted glass appearance. So this LED display and the 7 segment appearance shown in the figure. The number 2 where required means the terminal 8, 7, 3, 4 and 5 would be energized, and only those region would be the frosted while the other areas would remain clear. So here the 7 segment LED indicating for this kind of LED. So if required, the brightness is given for this needed to number 2 means this indicating for this where the terminal 8th terminal, and then 7th terminal, and then 3rd terminal, and then 4th terminal, and the 5th one terminal. This terminal is required to show in the number 2 to the help of the 7 segment displays. So the field, the effect are the reverse the 12 of the LEDs has the same segment appearance and thin layer of encapsulated liquid crystal, but it is the mode of operation is very difficult. Similar to the dynamic scattering LCD, the field effect LCD can be operated in the reflective or transmissive mode with an internal source. The transmissive display appear in this figure. Scalar and spacer, vertical light polarizes, glass, eye radiation, incident light, clear conductive surface, and horizontal polarization cannot get through the vertical polarizations. So this another one circuit diagram, the eye fluctuations. The reflective type field effect, that means the LCD in horizontal type, horizontal light polarizer, reflector, sealer and spacer, glass, incident light, eye, clear conducting surfaces, vertical light polarizer. In this case, the horizontally polarized light at the far left encounters a horizontally polarized filter and passes through to the reflector, where it is reflected back into the liquid crystal, bent back to the other vertical polarizations. Next one, Schottky barrier and hard carrier diodes. It is the recent year there has been increasing the interest in a two-terminal device referred to as Schottky barrier or surface barrier or hard carrier diode. Its area of application were first limited to the very high frequency range due to its quick response time, especially important at the high frequencies and a lower noise. The recent year, however, it is appearing more and more in low voltage and high current power supply and AC to DC converter. The Schottky TTL logic for computers, mixers and detectors in communication equipment, instrumentation and analog to digital converters. So this construction of conventional PN junction metal semiconductor junction is created such as the figure. So the lower arm is cathode and the negative terminal, and then upper is middle part of upper is called as anode. It is given to positive supply. The gold leaf metal is contact, and then semicon, that means the silicon dioxide screen, and the metal oxide semiconductor junction is using for this top side. The semiconductor is normally n-type silicon, although p-type silicon is sometimes used. While a host of different metals such as platinum, chrome or tungsten and used in these colors. Since in the conventional BM junction, there is an injection of minority carriers into the adjoining region. Here the electrons are injected into the region of the same electron polarities. The Schottky diodes are therefore unique in that conduction is entirely by majority carriers. The heavy flow of electrons into the metal creates a region near the surface diploid of carriers in the silicon materials. So this characteristics here, this Schottky diode characteristics using for this two material. The 0.3 volt is acting as a Germany material, and then 0.7 voltage is acting as silicon materials, that is called a normal PN junction diode. It will be operating for both the forward bias and reverse biasing operations. This operation of circuit diagram, that means the inductance value and then resistance value. This symbol of this Schottky diode using for this standard normal PN junction diode. So the name is anode and cathode. Here the LP indicating for the inductance and then the capacitance of this primary side. The package value of base resistance is series resistance, which include the contact and bulk resistance. Next one is variactor diodes. The variactor is also called as varicap, that means voltage variable capacitance or tuning. The diodes are semiconductor voltage dependent and variable capacitors. Their mode of operation depends on the capacitance that existing at the PN junction when the element is reversed. Under reverse bias condition, it was established that there is a region of uncovered charge on either side of the junction, that together the region make up the depletion region and define the depletion width. This is characteristics considering for applied voltage, applied reverse voltage in x-axis, and then the capacitance values taking for this y-axis. We can draw the same characteristics. This is some mathematical expression of total capacitance. C is equal to K divided by Vt plus Vr power n. So Vt is a new potential, and then Vr is the magnitude of applied reverse bias potentials. So it's a Schottky diode for different ranges using for different applications. And then final on the frequency of parallel connection of diode and capacitance using for this combination, that is called tank circuit. The tank circuit containing for one inductance and one capacitance, that is called a tank circuit. The formation is using for Fb is equal to 1 divided by 2 pi root of L2 Ct dash. Next one is photodiode. The interest in light sensitive devices has been increasing at an almost exponential rate in recent years. The resulting field of optoelectronics will be receiving a great deal of research interest as efforts are made to improve efficiency levels. Through the advertising media, the layperson has become quite aware that light sources offer a unique source of energy. This energy transmitted as a discrete package called photons. So the W is equal to hf joules. So where this is h is called Planck's constant and is equal to 6.624 into 10 power minus 34 joules per second. So another one is the frequency of lambda value V divided by F. So it's a photodiodes. It will be emitting the photons through the outside. So this junction is normally called as PN junction diodes. So this is waveforms. So it's a final expression for these things. Thank you.